Okay, maybe. Or not triangle, circle. So first thing I need is a circle, right? That's not bad. That's good enough. It's a little light, but good. We need an X and a Y axis, so we need to split it in half vertically and horizontally. So we label our axes. Okay, that doesn't look terrible. X and Y. What else did we do after that? We labeled degrees. Good. Where did we start? Good at X, and that was 0 degrees, right?
Yeah, 90. 80.
And then all the way back to the beginning was 360. Good. Now, next we did radians, and we should remember what these are. You should be able to see them on your paper. Do you remember what I multiply a degree by to get a radian? Pi over 180. So when in doubt, you can't see this on the Zoom screen. When in doubt, if you need to get a radian, take whatever degree you have, multiply by pi over 180. Good morning. This is F period. When?
I know, I'm off track.
I know, language though. I've got the F word on my YouTube page. I'm gonna get demonetized. No, I'm just kidding. I'm not monetized anyway, but software just walks in and drops the F-bomb. It's a little early for that. Okay, well, back to our lesson. Radians, we have them on our paper, so when in doubt, you can multiply, but you guys know what they are. What is it? 0 degrees is radians. 0. What's 90 degrees is radians? Pi over 2. What's 180 degrees is radians? 270. 3 pi over 2. And then last, 2 pi. Good. Or 4 pi over 2. Very good. Now, I also asked you to label the point. If you remember, we call this the unit circle. And do you remember why I said we call it the unit circle? Not equals pi. Good. The radius all the way around from any point from the origin anywhere on the circle is 1 unit away. So radius equals 1 unit. So I had us label the coordinate points. What point did we label that? 1, 0. What did I label the one up by 90? 0, 1. What did I label the one over here at 180? And then what about at 270? 0, -1. Good. Okay, now the last thing we did, and I don't know if we remembered this, I think I asked you guys to fold your paper in half again. So we essentially were cutting this first quadrant in half. When I asked you to fold, I think I told you to put your X and Y axis together to fold that in half. But we're essentially cutting all of these quadrants now in half again. So that goes in half. That's about half. And then I gave you those green triangles. And do you remember, did we talk about what these green triangles were? 45, 45, 90. And so all of these angles come from 45 degrees. Okay. If you put yours in after you folded it, it should line up really nicely. Now, my triangle is not obviously to scale with my shape, so it looks a lot smaller, but you could have taken your triangle, put the base on the positive X axis, put the 45 degrees by the origin, and it should have lined up really nicely. Should be perfect. So you could even do that now and see if it works. I think that's all we had done so far when we left, right? Did you guys have anything else on your paper? Okay, perfect. What we're going to do is label the rest of these in degrees. We're going to label their radians, and then we're going to come and I'm going to be able to tell you what their ordered pair is, okay? When we think about these, this little 45-degree triangle is what we call a reference angle. Basically, we're going from 0 up 45 degrees. Well, if we start at 0 and we go up 45 degrees, obviously we're at 45 degrees, right? I could do the same thing on this side though. And I would have been starting at 180 and I'm gonna go backwards 45 degrees. Whenever we have our triangle, whenever we do angles, they have to have the bottom, the base needs to be on the x-axis. So over here, I had the base on the x-axis. I just flipped it across and the base is still on the x-axis. If I was at 180 and then I minus 45 degrees, well, how many degrees am I at here? 135, very good. So this is 135 degrees. I don't really want you to draw these little arrows, but I'm going to draw them so you know where I'm going, okay? Same idea to get this green line over here. I was at 180, but now I am 45 degrees plus that 180. Where am I at now? 225, very good. 225. Good morning. And then last, if I was, now again, we're going backwards. If I was at 360 and I'm going to go backwards 45, where am I at for this last green line? 315, very good, minusing that. Each time we're essentially minusing or adding. So depending on where we're at, we're taking either 180 or 360 and we're either adding or subtracting to get to the next place. Okay, now let's do our radians, okay? For 45, let's start by actually doing our conversion factor. So we're going to do 45 times pi over 180. I'm going to argue the rest of them. We can do that way, or we can use our fractions to solve. So we're now going to do 45 times pi over 180. When I start simplifying that, what does that simplify to be? $45 and 180 have anything in common? Definitely have 5. So they definitely have 5 in common. So that becomes 9 and that becomes 36. Do 9 and 36 have anything in common? 9, right? So that becomes 1 and that becomes 4. So 45 is the same thing as pi over 4. So all of my 45, all of these green lines are going to be some kind of pi over 4. Okay. So let's do a little bit of fraction work. Pi over 4. Just like we did on the degree over here, remember I physically asked you, I go, oh, we're going to do 180 minus 45, and that gave us 135, right? Let's do the same idea with radians. We're going to do pi minus 45, which is pi over 4. Now, if the pi's are tripping you up, just treat it like it's a 1. 1 pi minus 1/4 pi. What do we have now? 3/4. Good. So this is going to be 3 pi over 4. Similarly, we're going to get to the 225. When we did our degree, I asked you what's 180 plus 45. We're going to now do pi plus pi over 4. Or again, if you don't like the pi, think of it as 1 plus 1/4. What does that give us? 5 pi over 4, 5/4. And I think the last one is the hardest just because we're going to have to convert this. This I asked you to do 360 minus 45. So we're going to do 2 pi minus pi over 4. And even if you take out the pi's and do 2 minus 1/4, I don't want a mixed number. I still want an improper fraction. So you may need to make that 2 into 8 over 4. 8/4 minus 1/4 is 7/4. So this is going to be 7 pi over 4. Okay, how are we doing so far with that? Good. Okay, I'm going to bring us to the other side of the board because I need to talk about special right triangles, okay? So special right triangles is something I taught you back in geometry. Now, have you slept between now and geometry? Yeah, probably. Do you remember when we learned about special right triangles, 45, 45, 90, 30, 60, 90? What'd you say? Yeah, we did a lot of fun things in geometry, but one thing we did that I think was maybe our least favorite, but that's okay, was these special right triangles. The 45, 45, 90s, the two legs were the same, and I think I generally just called them one. And then the hypotenuse, does anyone remember what that hypotenuse was? Or what we did to multiply by the leg to get to the hypotenuse? Square root of 2. Square root of 2, good. Okay, now the problem is though, is that the little triangle I gave you though, it doesn't say that the hypotenuse is root 2. What does it say your hypotenuse is? 1. So we want this to actually be 1. So what do we need to do to root 2 in order to make that 1? Divide it by root 2, divide it by itself. So I'm going to divide everything here by root 2 so that I can get 1 as my hypotenuse. That's because in my unit circle, as we talked about, 1 is the distance any point that's from the origin to a point on the circle. So this length right here is 1. I want to know what its horizontal length is, what its x value is, and what its y value is. So I care about these two sides right here. Now I can't write 1 over root 2. Can we rationalize that? Multiply by root 2 on top and bottom. So I've got root 2 over 2 and root 2 over 2. And you can even write that on your little triangle. There's a box along the bottom that you can write root 2 in. There's a box along the side that you can also write root 2 in. Those are those lengths, the horizontal and the vertical lengths. Now, I don't want you to draw this on your shape. I'm about to draw it on the board, but you can think about the triangle on your unit circle. Notice that when you lay it flat, the corner of the triangle goes all the way to the end. So that is your 1 unit. That like line that we wrote 45 on, that's your 1 unit. Your x value, how far over you went, is that bottom length. It is going to be 2 root 2. No, I lied. It's going to be root 2 over 2. Sorry, my words are a little messed up already today. The x value, the coordinate points we're about to write, your x value for 45 is going to be root 2 over 2. And then your y value, the distance you went up and down, is also going to be root 2 over 2. So I'm going to draw the triangle on the board over here, but you can just visualize it with your triangle. So basically what we're doing in order to find this is I'm looking at, okay, I went over root 2 over 2, and I went up. Oh, shoot, I did that wrong. That looks a little bit better. And I went up root 2 over 2. So that means the ordered pair that I get to write at 45 is root 2 over 2, comma root 2 over 2. Now I asked you to color coordinate because every green line has the same coordinate point. What's going to change as we change quadrants is the positive and negative value of each one of those. So when I come over here, it's still going to be root 2 over 2, root 2 over 2. But is my x going to be a positive or a negative value if I went this way? Negative. Is my y going to be positive or negative if I went this way? Positive. So see how that's the exact same point, but it's a negative root 2 over 2 for the x and a positive root 2 over 2 for the y. Now I want you to put the coordinate points in. Don't write this line in, but
Don't draw the triangle.
don't draw the triangle. If you drew the triangle, it's okay. But I wouldn't. It makes it a little bit messy because we're going to put a bunch of other lines on there in a second. I just drew the triangle so you could see why I knew that. I'm going to come down to this quadrant right here. What are my x's and y's going to be here, positive or negative? Negative. So it's going to be a negative root 2 over 2 and a negative root 2 over 2. Both the x and y are negative in that third quadrant. And then what about in the fourth quadrant? Is the x positive or negative? And is the y positive or negative? Negative. One thing you might want to write on your paper, this is something we did back in like algebra 1, was what are the qualities of each of the quadrants. Quadrant 1 is a positive, right? Quadrant 2, the x value is always negative and the y value is always positive in quadrant 2. Quadrant 3, both x and y are negative. And then in quadrant 4, the x is always positive and then the y is always negative. So that's something that I might write on my shape, so then I know I can double check. I can go, okay, are both my X and Y positive here? Check, we're good. Okay. Are you ready for another triangle? Okay. If you don't have another color, get another color right now. I'm about to give you a yellow triangle. First person, once I give it to you, take one, pass it back. If for some reason I didn't count right, let me know, or if you have too many, let me know. I've got colors right up here. If anybody needs a color, they're in that kit and caboodle. I don't know. It's fun. Shape that. Okay, what I want you to do now with your new color, and maybe use a pencil to trace it first, but we are going to take our new yellow triangle and we are going to trace it on our shape, doing our reference angles that we did before. So we're going to start by taking our yellow triangle and putting the base on the positive x-axis and the 30-degree angle, the small angle, close to the origin. And you're going to trace that line. It should be somewhere between the black line and your green line. It's going to be somewhere between 0 and 45. I'm not going to be able to trace it well, so I'm just going to freehand it. It's somewhere in here. Okay. Once you've done it on the first quadrant, I want you to flip your triangle over. The 30 degrees is still going to be at the origin, and the base of the triangle is still going to be on the x-axis. And again, your new line, mine is blue, it's going to be in between my green and my black line. Then I'm going to flip it over the x-axis. Again, my 30-degree angle is still at the origin. In the third quadrant, the blue line is still between the black and the green line. And then in my fourth quadrant, same thing. The 30-degree is as close to the origin as I can. The base of the triangle is on the black line. And I'm going to trace that line, and it's going to be in between the black and the green line again. If you use a pen or a pencil just to start, once you have those, trace it around. I just did my blue lines on here. They're the closest to the x-axis. In between my 45 and my quadrant. Did you get purple chase? Does look good. There's a little rough, but they're at least in the right place. It's not gonna be directly in the middle. If it was directly in the middle, I'd have you hold it.
Oh, yeah.
That's why you're. That's okay, that's okay. As long as it's in between the lines, that's really all I care about right now. Okay, you're in the right spot. Oh, yours look good. Does anybody need me?
It's like not good.
Are they the blue lines? Okay, these two are right, and then that one's right, this one's wrong. So once you don't erase that one though, I want it to be. Like right. You're gonna need that other blue line in a minute, so ignore it. You're just moving this line closer to that. Not yet, no, give you that. Those look good enough. They're where they need to be. Does anybody else want me to check theirs? Yours are where they need to be. Okay. Let's label these with degrees and then we'll do radians, and then we'll come back to special rate triangles. So I just told you this was, did I say 30 degrees yet? Did I make that up in my head? I told you that?
Yeah.
Did I say that? Okay. This little guy is a 30 degree. This big guy up top is a 60 degree. We'll deal with 60 in a second. We only care about 30 right now, which is why I told you the small angle always had to be close to the origin, okay? So these blue lines are all a reference of 30. Where'd my blue marker go? So this first blue line, it's between 0 and 45. It's going to be 30 degrees. Okay. Now, same math that we just did a minute ago. To get the blue line in the second quadrant, we're going to do 180 minus 30. What's 180 minus 30? 150. So this blue line in the second quadrant is 150. I really should have gotten a new marker today, but I didn't. So good enough. Okay, the blue line in the third quadrant, same idea. Now we're going to go more than 180. So what's 180 plus 30? 210. As long as it's somewhere on that line, I don't care. And then last but not least, the blue line in the fourth quadrant is 360 minus 30, which is going to be 330. Very good. And it should make sense. If you look at your lines, do you notice that it just gets bigger? I'm literally counting up 0, 30, 45, 90, 135, 150. They're not switched in some weird order. They're not going by the same increment. That's okay, but they're getting bigger as we go around. Is everybody okay with the degrees? Okay, now let's do our radians. To find our 30 degree as a radian, let's do our conversion. All right, 30 times 180. Get rid of the 0. So now I've got 3 and 18. Do 3 and 18 have something in common? A 3. So I'm left with 1 and 6. So 30 degrees are pi over 6. All of those blue lines are going to have a pi over 6. The number on top in front of the pi is going to change depending on where we're at. So the first one, 30 degrees, is just going to be our pi over 6. Okay, everybody's fraction game is ready to go. Same thing that we did over here, 180 minus 30, or pi minus pi over 6, or 1 minus 1/6 is how many 6? 5, 6. Very good. 5 pi over 6. As long as that goes somewhere on your blue line, 150 is 5 pi over 6. Same idea for the third quadrant. This time we're going to add it. Pi plus pi over 6. 7 pi over 6. Sorry, I know this marker sucks. If you can't read it, let me know. I'll erase it and try again. And then last but not least, at 330, this is again the hardest one. We're going to do 2 pi minus pi over 6. And again, we can think of 2. Let's make 2 a fraction with 6 as the denominator. That'll be what over 6? 12 over 6. So 12 over 6 minus 1 over 6 is how many 6? 11 6. 11 pi over 6. All right, guys, you're killing it. How are you feeling so far? Feeling good? All right, are you guys ready to figure out what our coordinate points are for all of these blue points? All right, join me on the other side of the board with your little yellow triangle. It's gonna have to be good enough. Okay, I know we kind of talked through our 45, 45, 90. We had them labeled 1, 1, and root 2. Does anyone remember what we labeled the 30, 60, 90 triangle sides? And I'm asking you to go back to the depths of your memory. 2. One of them is 2. Do you remember which one's 2? The hypotenuse is 2. Good, Ryan. The hypotenuse is 2. Root 3. Yes, Quinn, where does that one go? With the 30 or with the 60? 60, good. And then the last one is just 1. So 2, root 3, and 1. Okay, now, if you notice our little shape does not say 2 as my hypotenuse, what does it say I want my hypotenuse to be? 1, so what do I need to divide all of these by? 2. 2 divided by 2 is gonna be 1, so that makes my hypotenuse 1, which is what we wanted it to be. We're gonna do 1 divided by 2. I want you to leave that as a fraction, so it's just gonna say 1/2. So that's my vertical length on your little yellow triangle. The vertical length is 1/2, and then √3 divided by 2. Can we simplify that / do we need to simplify it? No, it's ugly, but that's what we want. √3/2, that's your bottom length. So when I do these 30, 60, 90s, which of these is my X value? Which one's your X? √3/2, and then that makes our Y 1/2. So all of our points, all of my blue lines over here, whatever color you have here in your paper, they're all gonna be √3/2, 1/2, but the negative and positive is gonna depend on the quadrant you're in. Okay, let's go do that. So the first one is positive, positive, positive √3/2, positive 1/2. The second quadrant is negative. So negative √3/2, positive 1/2, bless you. Third quadrant, they're both negative. And then fourth quadrant, Y is negative. Okay. Awesome, we got one more triangle. Here comes a pink one. Yeah, so like this one, you'll notice that there's like those 2 lines, like you already have that. So you don't need to do this, I maybe just trick them over to the color. But you'll need to do the 2 lines up here. And then you have to. Okay, does anyone know anything about, recognize anything with this pink triangle?
30 is on top.
Good, 30 is on top. These 2 triangles, the pink and the yellow one, are basically the same. Like I can put them on top of each other, but the way I have them oriented is they're still 30, 60, 90, but in the yellow one, the 30's on the bottom, and in the pink one, the 60's on the bottom. Okay, so I want you now to take this pink triangle and we're gonna trace lines with this. Now your lines should be between the green and the black. They should be in between the 45 and the 90, or the 135 and the 90. So go ahead and take your pink triangle and trace the 60-degree lines on your paper. Mine are going to be in red if you need to look at mine. I'm going to come around if you need help. They should be the tall ones. Mine are pink on my. So all of yours will be between your blue and your black. Yeah. Yeah, that's what. It's going to be, here is your 0, and then it's to be like that. The base of the triangle is always on your x-axis, and then that 60 degrees is right. So all of yours are going to be in between your pink or your red. That one was good. Now I want to do this one. I want to do this. You look so good. Along the green line, and then I want that 60-degree always be. The right one. Not right. Okay, you good? Yeah. Oh. The pink is. Okay, good. I was like trying to read, so I'm like, what am I looking at here? Your dark purple that you do, that's like good. Those ones are new, yep, those are good. Red ones are new, those are good. You guys good over here? My yellow line. Your yellow ones are new. That happens sometimes. Okay, guys, so we're gonna label these red. My lines are red, whatever color yours are, the new lines that we drew. We're gonna label them with 60. My first one is 60 degrees. What's my second angle? Hey, everybody, join back with me. My red ones here are 60. 120, I can do 180 minus 60 to get this one in the second quadrant. Ooh, that's awful. 120. What about in my third quadrant? 180 plus 60 is going to be how much? 240, good. And then what about 360 minus 60? 300, good. All right, so my degrees, 60, 120, 240, and 300. Now let's put them into radians. So now I'm gonna do my math again. We're gonna get the radian version of these. So 60 times pi over 180. How can I simplify that? Pi over 3, good. I didn't mention this to C period, I forgot, but notice that 30 goes with pi over 6, 60 is going with pi over 3. I just remember that the radians and degrees are not going to match. So I want 30 to go with pi over 3, it doesn't, it actually goes with pi over 6. I want 60 to go with pi over 6, it doesn't, it goes with pi over 3. So just flip what you think it should be, and that's the correct one. Okay, I think 60s are actually the easiest ones. If I have 1 pi, and I'm going to minus pi over 3. What's 1 minus a third? 2/3, good. 2 pi over 3. So I go pi over 3, 2 pi over 3. You can even think of pi as being 3 pi over 3. So what's the next one going to be? 4 pi over 3. We went 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. What's this one going to be? 5 pi over 3. Which makes sense because 2 pi is the same thing as 6 pi over 3. Thank you. You don't need to write those 6 pi's over 3 and 3 pi. That's going to be super annoying. Okay. I'm not even going to have to do that much work. I'm just going to flip this triangle. So instead of it being a 30 as the base, I'm going to write it with 60 as the base. Sorry. Based on what we just talked about, if the hypotenuse is still 1, the side across from 30 that's now the bottom should be labeled as what? 1/2. And then what should that vertical side across from 60 be labeled as? √3 over 2. Now my ordered pair, what's my x value? 1/2. What's my y value? √3 over 2. Do you see how it's the exact same point as what we just did, but we just switched the x and y? We're going to go do that for all of our 60 points. So for all of your red lines, all of your 60 degrees, we're going to write 1/2, comma √3 over 2, and then just make sure what's positive is positive, what's negative is negative. Okay. So let's bring it back over here. We're almost done. You guys are doing so good. So positive, positive. Negative, positive. Negative, negative. And positive, negative. Okay. Once you have that, we have done our unit circle. Now I'm going to tell you why we did this and why this is helpful. Okay. So every single line should have degree, radian, and then an ordered pair. Degree, radian, ordered pair. Okay. You guys ready to know why we did this? Ready. All of my ordered pairs go X, Y, correct? They also go cosine, comma, sine. What we just did is I don't even know how many angles are on here, but I took all of these angles and now you can look at this and you know what the sine is and what the cosine is. So I can say, hey guys, what's sine of 135? Well, sine goes with your Y value. What's your Y value at 135? Root 2 over 2. Boom. If you put that in your calculator, that's what the sine would be. If I said, hey, what's cosine of, I don't know, 330? What's cosine of 330? Well, cosine's your X value. So we go to 330 and we get root 3 over 2. Isn't that crazy? And we could do this all day. These are the important ones that you will need to know, that we're going to know by heart, and that are going to come up in this chapter and the next chapter. Okay, let's go even further. Do you guys remember when we did BFFs back in the first semester? Do you remember what the sine BFF graph looked like? It's wavy, right? What did the cosine one look like?
Pretty much same thing.
Pretty much the same thing. What was the one difference? I said you must know this one thing about them. Which one goes through the origin? Sine. Okay, wait. Time out. That's at 0 degrees. What's your sine at 0 degrees? What's your cosine at 0 degrees? 1. Do you remember when we did cosine? We said cosine starts at 1.
Oh.
Wow, look, we can build this wavy thing. So instead of just going scribble, 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 now we're going to care about just 5 points. We care about the quadrant angles. I care about 0, 90, 180, 270, 360. If you notice, then I go back in a circle and I do it all over again. That's why it's wavy, is because it keeps going around and around in a circle. So let's do it. Sine of 0 was 0. What's sine of 90? 1. So my graph goes up. What's my sine at 180? 0. Sine's of Y. 0. So it comes back to the origin, or back to the x-axis. What's my sine at 270? -1. Now I go below. And then what's my sine at 360? 0. My sine graph looks like this, and then it just keeps going forever and forever. Let's do cosine. Same thing. It's going to give you that exact same curve, but instead of starting at 0, it just started at 1. So everything's just shifted over. What's my cosine? So now we're looking at x's. Cosine at 0 is 1. What's my cosine at 90? 0. What's my cosine at 180? -1. Remember, cosine's x. What's my cosine at 270? 0. And then what's my cosine at 360? 1. And then again, it's a circle, so I could keep going around and around and around. It's going to keep cycling around and around and around. Isn't that cool? Okay. I want you to actually get your notes out. We're gonna do one quick thing and then I'm gonna let you work on your unit circle for the rest of class. I want you to get your notes out and find section 4.2. Find section 4.2. Let me get my notes out. We're just gonna do 3 tiny problems really quick for me to really sell home what we're doing and why. It's gonna be good enough. All right, once you get to section 3.2, I want you to come down to number, or 4.2, come down to number 3. You guys all on 4.2, come down to number 3. 2 of these problems are on the back side of your paper, that's okay. With your unit circle, we do this with the exact values and we're gonna do this without a calculator. So the first one, letter A says sine of pi over 3. Which value is sine, X or Y? Y, can you go find the Y of pi over 3? What is it? Root 3 over 2. That's it. That's your answer. Oh, that's cool, right? Now, all we did is we went to pi over 3 on our unit circle, and then we went to the sine value or the Y value. So we went to the Y value at pi over 3. If you go put in your calculator sine pi over 3, you will get the decimal version of 3 pi over 2. Cool. Now, the next one says SEC. Do you guys know what that means yet? No, I'll teach that to you next week. We'll skip it. We'll skip tan for 1 second. We'll come back to it. Let's go do cosine. Cosine of pi over 3. Look, we're still looking at the same angle, but now we're looking at which value? The X. What's your X value of pi over 3? 1/2. Boom, the end. Okay. Now, tan is just a little bit different. Tangent is the same thing as sine divided by cosine. So in terms of X and Y, what can I do to find tangent? Divide them, which one goes on top? Y, good. Since sine is on top, we can find tangent by doing Y over X. Now, it's not as easy as just identifying X and Y, but it's pretty simple if I can just divide 2 fractions, right? So jump back to C, it says find tangent of pi over 6. What's your Y at pi over 6? 1/2. What's your X at pi over 6? Root 3 over 2. Now, this isn't really an easy problem. It's not an algebra 1 problem, but it's at least an algebra 2 problem, right? We can take 2 fractions and divide them by multiplying by the reciprocal. So I can multiply 1/2 by 2 over root 3. My 2's cancel. And I get 1 over root 3. Is that the best answer? No, let's rationalize that. Multiply by root 3 on top and bottom. So my final answer here is going to be root 3 over 3. And again, if we got our calculator out and put tan of pi over 6, that's what we would get. Okay. So we're going to use this a lot more. I don't know if we'll use it much more this week. I don't know how many more times I see you, but we'll use it at least next week and then really for the next 2 units. So I wanted you to build this unit circle so we can start using it and start getting familiar with it. We've got about 5 more minutes in class. I'm going to give you this nice clean sheet of paper. That's basically what you have. And I want you to take your paper plate and make it nice and pretty here. I suggest using colors. I also suggest writing this stuff on the side of your paper too, just because I think this is important stuff that we're going to want to remember later on. This is your homework. So tomorrow I'm going to come around and if you have this done, I'm going to give you a nice little check mark and you get a 10 out of 10 for homework. Easiest 10 out of 10 we're going to get. Okay. And so you got the next 5 minutes to work on this. If you want to keep your paper plate, by all means do it. If it's trash, after you make a copy of it, make it look pretty, then you can throw it away. But if you're like, mine is a work of art, keep it. What's up?